I am Iron Man. The suit and I are one. Spoken by Tony Stark in the first Iron Man movie, these words speak to the potential of an exoskeleton, a device that works alongside humans to achieve physical tasks. While today's exoskeletons don't grant us the ability to fly or possess superhuman strength like Iron Man, they are widely used in industrial settings around the world. These devices are crucial because, despite the increase in human automation, human involvement is still essential in many physical jobs. The main purpose of existing exoskeletons is to reduce the risk of injuries caused by repetitive tasks. However, there is a growing need for more versatile exoskeletons that can help with complex tasks. Complex exoskeleton development is time-consuming and expensive. A major challenge faced by leading exoskeleton projects is that after designing, building, and testing, they often discover that their exoskeletons hinder human performance instead of enhance it. Consequently, complex exoskeletons are not currently in use. So, if we want to realise our Iron Man-inspired dreams of flying to work, how can we improve our chances of designing functional, complex exoskeletons? This is where I come in, a real-life research superhero. I've proposed that new design methods would increase the quality and adoption of exoskeletons. So, I've developed an innovative design process which involves several stages of computer simulation. First, I create a 3D design for a new exoskeleton concept. Then, I apply this exoskeleton to a detailed human biomechanics model. Finally, I simulate the work task with the human model, generating valuable data on the impact of the exoskeleton on the body. This data guides where improvements can be made in order to build a higher quality and thoroughly tested exoskeleton. Through this process, I've already designed a new exoskeleton which shows an impressive 20% reduction in muscle strain around the spine. I will now conduct an experiment to validate the practicality of this design process. It is important to me that the exoskeletons I develop cater to the needs of a broad range of individuals, regardless of their race, gender, or ability. To achieve this, I will include a diverse group of participants in my experiment and continuously reflect on my research approaches. My research contributes to the widespread adoption of exoskeleton technology with the goal of reducing workplace injuries. And one day, it may even provide you with your very own Iron Man suit.